This is module AS2 and June 2011, and we'll be looking at question 2. So this question is looking for us to determine the molecular formula of the alkene in question. And so we're told that the alkene reacts with chlorine to produce a dichloroalkane. And how we work this one out is that we know that when an alkene, any alkene, so we'll give it the general formula, it has to have a CC double bond. And then R can be any alkyl chain, or it could be hydrogen itself, which would make it ethene. When it reacts with chlorine, the chlorine adds across the double bond and it gives us a saturated compound, which is the dichloroalkane. So the chlorine adds across the double bond and we can see that it's now saturated. And when we look to balance that equation, we can see that it's already balanced. So 1 mole of the alkene will react with 1 mole of the chlorine to produce 1 mole of the dichloroalkane. So how do we work out number of moles if we don't have the molecular formula of either the alkene or the dichloroalkane? Well, because we've only got one product, we know that the 3.8 grams is of the dichloroalkane and that there's no other products. So the total mass of our products is going to be 3.8 grams because there are no other products. And the mass of the alkene that we used is 1.4. So we can get the mass of chlorine used, by taking 3.8 grams and taking away 1.4 grams from that. And that gives us 2.4 grams. The reason we can do that is because the total mass of the products is going to equal the total mass of the reactants, because we can't create mass or lose mass. So because we've only got one product, we know there's no other mass going to be produced, and so we can work out the mass of chlorine used that way. From that we can then go on and work out the number of moles of chlorine. So I'll just rub this out. So the mass of chlorine used is 2.4 grams. Okay, so 2.4 grams of chlorine. The number of moles of that we can then work out by doing mass over RFM, which equals 2.4 over 71. Make sure you take the RFM of Cl2, not just Cl. And that gives us 0.0338 moles. Okay, then we can then work out the number of moles of alkene that we used by bringing this over to that part of the equation. We can see that it's a 1-to-1 ratio, and so we used 0.0338 moles. From that we can work out the RFM by rearranging our equation, this equation here, to get RFM equals mass over the number of moles used, which is 1.4 grams from the question over 338 moles. And that gives us an RFM of 41.4. So it's not a whole number, but we'll be looking for an alkene that has an RFM of similar to that. So if I then work out the relative formula mass of my alkenes, C2H4 has an RFM of 28. So we've got 2 carbons, which are 12 each, that's 24, plus 4 hydrogens is 28. C3H6, we're just adding a CH2, so we're adding 14. That has an RFM of 42. And you can see that's close to our answer of 41.4, so the answer is B. The relative molecular mass of our alkene is 42, which corresponds to a formula of C3H6.